Hello, my name is Chantelle Albecker, and today I'll be presenting my Introduction to Materials Science final project, which focuses on crystallization in nature, in industry, and I will be also presenting my 3D model, which involves crystal growth. Alright, so the aim of this project and presentation is to introduce the concept of crystallization. I'm also going to explain and give examples of crystallization that you see in nature and industrial applications. I'll explain multiple terms like what a crystal structure is, what a unit cell is, and so forth. And finally, I'll be comparing and contrasting two different crystal growth experiments I performed, which will be my 3D model, as a fun way to show everyone how different substances produce different crystals. So what is crystallization? Crystallization is the process by which atoms or molecules of a substance arrange themselves in a well-defined 3D lattice and in order to minimize the overall energy of a system. There's some terms that you will hear along the way, which would be crystal lattice, the geometrical arrangement of atoms, ions, or molecules of the crystalline solid as points coinciding with an atom's positions or sphere centers. The crystal structure is the manner in which atoms, ions, or molecules are spatially arranged. The unit cell is going to be the smallest portion of a crystal lattice and is a repeating unit. So, as an example, there are common types of crystal structures: simple cubic structure, body center cubic structure, and the face center cubic structure, which often occurs in metals. For the simple cubic structure, which will be the first photos shown down here, there is an atom in each corner of the cubic structure with one atom per unit cell. For the body center cubic structures, atoms exist in each corner as you see here, with an atom in the center of each structure. The structure has 2 atoms per unit cell. The face center cubic structure has atoms existing in each corner as well as an atom in the center of each face, as you see here. This structure has 4 atoms per unit cell. So crystallization is often performed in industrial applications as a separation process. For example, in the pharmaceutical industry, it is used as a separation process for intermediates that are not needed and thus serves as the final step to capture the active ingredient to make a drug. Crystallization is also used in wastewater treatment. It is used to recover substances such as NaCl, Na2CO3, phosphates, and so forth to make sure that wastewater is less toxic to the environment. Crystallization in the industry means it is to crystallize a solute from a liquid solution into a pure solid crystalline phase. There is also crystallization that occurs in nature, such as the rapid cooling crystallization of water to form ice cubes or snow, which you see right here on the fence. And then crystallization actually occurs in nature when creating caves, where you have stalagmites and stalactites, which is the process of water being supersaturated with calcium carbonate, and it eventually redeposits it along the ceilings and floors of the cave, which leads to these structures, and it takes millions of years to form. Alright, so now I'll be discussing my 3D model. My first model is crystal growth using Epsom salt, which you see in this container on the right, and then I did rock candy formation, which took a couple of days to do. Alright, so for the first experiment, it was a very easy experiment. You just use magnesium sulfate, which is commonly known over the counter as Epsom salt, food dye if you want to, just to better visualize the crystals that are formed, a 300 milliliter beaker, kettle, measuring cup. So my method for this is that I stirred half a cup of Epsom salt with half a cup of hot water for at least a minute to create a supersaturated solution. I added blue dye coloring and then stirred it to make sure it was in the solution properly. And then lastly, I placed the mixture in the fridge overnight and poured off the remaining solution the next day to observe the crystals form. So this is how my crystals ended up looking. You can see there's a little bit of solution still at the bottom, but you see that the crystals are very sharp. If you zoom in right here, you'll see that it's a very sharp structure. And this is an example of cooling crystallization, as I mentioned, most often used as a technique in wastewater treatment. Alright, for my second experiment, I did rock candy formation. It was also another simple experiment that could be performed at home. It required a bag of white granulated sugar, a cup of water, wax paper, craft sticks, skewers, a saucepan, food coloring pack if you wanted to, and measuring cups. Alright, So this is my general methodology to do the rock candy formation. The first thing you do is you dip the craft sticks or skewers in water, then lightly coat them with granulated sugar. Then you lay them on a sheet of wax paper to dry. You do this so that when you put it in the supersaturated solution, it can then grow on it, and it grows that rock candy formation you see at the end. Right. Then 1 cup of water is poured into a saucepan along with 1/2 cup of sugar. You stir constantly and keep adding in the sugar with 1/2 cup intervals until no more sugar can dissolve and the resulting solution boils and becomes clear. I then took the pan off the heat and waited for the solution to cool until it was a little bit warm. Then I poured the solution into 4 separate cups and dyed each solution a different color just for the fun of it. And then I placed the sugar-coated craft sticks into each solution and stirred the solution with the craft sticks every day and observed the crystals growing. If you look at these pictures right here, you'd see on the very far right, the green crystal right there was very minimal growth. That was day 2. You can see a little bit forming around the stick because you can see the stick in it. Around day 4, I had a lot more crystal growth going on there. And then I removed it after 5 days. Typically, it takes about 7 days or more for it to actually fully grow, become the rock candy that you would know from the market or wherever you would get it. And this is all the crystal structures that form for it. So in conclusion, crystallization is used in the industry and occurs naturally in nature. Each time crystallization occurs, a unique structure is formed as seen by my experiments. Not all crystals will form or look the same. Thank you for listening, and I hope you enjoyed my presentation.